today we're going to talk about the union and intersection of events. And this is dealing really with one trial experiments, but two events happening. So I want to talk about union and intersection, and it's easiest to look at using these Venn diagrams. So if we're talking about event E and event F, this symbol means the intersection. So we're talking about the intersection. This symbol means union. So let's write those down. This is intersection. And this is union. So if I'm talking about E and F both occurring, I'm talking about that intersection where they're crisscrossing, where they're both happening at the same time. If I say I want E or F, then I want everything in E, everything in F, and I'm okay with the places where they're combined. So that would be the union. The probability that E does not occur is denoted by this E dash. That means not E. So here's E, not E would be everything else. And we might be using those symbols just to help things out, okay? So intersection is and, union is or. So a card is drawn from a box containing 15 cards numbered 1 to 15. Okay, so we know that our sample space is 15 items, all the cards 1 to 15. What is the probability that the card is even and divisible by 3? So it might actually help for us to make a Venn diagram of this one. So here's my world of the numbers 1 through 15. I'm going to have the world of, let's call E for even. Ooh, E for even. And, well, I may not have room. Okay, this will work. D for divisible by 3. So let's go through each number and see where it places. 1, not neither one. 2, 3, divisible by 3. 4, 5, 6 is even and divisible by 3, so it goes in the middle. 7 is neither. 8 is even. 9 is divisible by 3. 12 is both. 13 is neither. 14 is even. And 15 is divisible by 3. So even and divisible by 3, that's that intersection, the ones that meet both conditions. The probability of being even and divisible by 3 is going to be how many we have in the intersection. So that's 2 out of the 15 possible. But if I say even or, if I listed all of those options out, it'd be everything inside of here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. Wait, 1, 2, 3, 4, 8, 9. I feel like I'm missing one. 4, 5, 6, 7, 8. I forgot 10. Oh gosh. How did I count and not get 10? Okay, so there's 10 of them in there. That's 10 out of 15. Or you could write that as 2/3. Not even would be everything that's not in the even circle. So notice the even circle includes that 6 and 12. So I'm going to cover those up. Everything else would be 1, 2, 3, 4, 5, 6, 7. I'm missing something else. Hold on. I missed 11. I can't count. Because it should be 8 of them. Oh my goodness. So if you're making a sample space, make sure you don't forget anything or else you will make a mistake. Heads up. So we kind of looked at the probability of not being an E. And so we can actually take the probability of being inside of E and do 1 minus that probability. That's a kind of a shortcut for it. So let's take this one. Suppose that a 50-year-old man has systolic blood pressure of 110 and that 60% of his cholesterol is HDL. The risk of heart attack in the next 10 years is given in the following table. So these are in percents of the risk of heart attack depending on the total cholesterol. So I missed part of what it was supposed to say. Suppose the man has a cholesterol level of 200. What is the probability he will not have a heart attack? Well, the risk that he will have a heart attack, so the probability of having a heart attack, is 2%. So the probability of no attack would be 1 minus that. All right. Now, if we have two events, E and F, then the probability that one event or the other will occur is that E or F, right? That union of the two. So one way we can find that union is we could take everything in E plus everything in F and then subtract out the ones that we've counted twice, which would be that intersection. So everything in E plus everything in F, but subtract out that intersection. So suppose that in a given year, the probability that the Steelers will win their division is 1 in 6. And the probability that the Jets will win their division is 1 out of 12. And the probability they both will win their division is 1 out of 24. What is the probability that one of the other teams will win? So first off, we got to find the probability. This should just say one of these teams. I'm sorry. One of the teams will win their division. So the probability that one of them will win is the probability that the Steelers or the Jets win. I have so many typos on this paper. I'm so sorry. So we take the probability that the Steelers will win plus the probability that the Jets will win. But there's probabilities inside there of them both winning, so we have to subtract out them both winning. So this was Steelers, Jets, and then the both. Oh, and I feel like doing this by hand. Don't know why. That would be 4 out of 24. And that would be 2 out of 24 minus 1 out of 24. That's 5 out of 24. The directors of the Chatham County School Board consist of 8 Democrats, 3 of whom are female, and 4 Republicans, 2 of whom are female. If a director is chosen at random to discuss an issue on television, what is the probability that the person will be a Democrat or a female? So the probability of being a Democrat or a female. So what we're going to do is we're going to take the probability of being a Democrat plus the probability of being a female and then subtract the probability of being both Democrat and female. So how many Democrats are there? Well, there are 8 out of how many total people are on the school board? Well, they tell us that's 12. How many total females are there? 5 out of 12. And how many are both Democrat and female? That was 3. So that would give me, what, 10 out of 12? Or 5/6. All right. Now, sometimes we have what are called mutually exclusive events, where it couldn't be both. Then we don't have to worry about the overlap. Like, find the probability of obtaining a 6 or a 4 in one roll of a die. Well, there's no way I can roll both at the same time. So that would just be the probability of getting, so the probability of 6 or a 4 would be the probability of getting a 6 plus the probability of getting a 4. And that's a 1 in 6 chance plus a 1 in 6 chance. That's 2 out of 6 or 1/3. A firm is considering 3 possible locations for a new factory. The probability that site A will be selected is 1/3. The probability that site B will be selected is 1/5. Only one location will be chosen. What is the probability that site A or site B will be chosen? Well, that's the probability of A or B. So that's going to be the probability of A plus the probability of B. So the probability of site A was 1/3 plus 1/5. And that's 5 over 15 plus 3 out of 15. That's 8 out of 15. Now the probability that neither is chosen would be the opposite of that. Probability of neither would be 7 out of 15 because it's the rest of the options. Find the probability of rolling 2 distinct dice and obtaining a sum greater than 9. So we need to talk about how to get a sum with 2 dice. Okay, so this is going to be my picture for the sums. So on one of the dice, I could roll a 1, a 2, a 3, a 4, a 5, or a 6, right? And the other way is going to be a 1, a 2, a 3, a 4, a 5, a 6. So the sum of the 2 dice would be 1 and a 1, it's a 2. 1 and a 2, 3. 1 and a 3 would give me a 4. So we're adding the faces of the 2 dice together. 2 plus 1 is 3, 2 plus 2 is 4, and you'll notice a pattern here. 3 plus 1 is 4, 4 plus 1 is 5, 4 plus 2 is 6, and so forth. 5 plus 1, and then 7, 8, 9, 10, 11, and 12. A sum greater than 9. So that would be a 10 or 11 or a 12, right? Probability of being greater than 9 would be the probability of getting a 10 or an 11 or a 12. So the probability of getting a 10, there's 3 of them. out of, ooh, how many do we have? 6 by 6, that's 36. Probability of getting 11 is 2. And the probability of getting a 12 is 1. So that would be 6 out of 36, or 1/6. Probability of a 6 and a sum greater than 9. So that's the probability of a 6 and greater than 9. So we need to take and actually look at this one. This one we have to try to find that intersection of a 6 and a greater than 9. So that would be here, 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 and here. So that's how many? Oh, wait. It says 6 on the first die. Oh, so that does make a difference. So that would be rolling a 6 and then a 4, 6, then a 5, 6, then a 6. I couldn't roll it the other way, so that's only 3 out of 36. That's 1/12. So sometimes you have to actually break it down and figure out what could happen. So 6 on the first die, or a sum greater than 12. Okay, so probability of 6 or the probability of or greater than 9. So this one, do we have an overlap? We do. So we want the probability of getting a 6 plus the probability of being greater than 9 minus the probability of 6 on the first die and being greater than 9. So probability of getting a 6, let's see how many different ways we could just get a 6. Oh, 6 on the first die. There's only 6 ways to do that. Sorry. So that's 1 out of 6. Then the probability of getting greater than 9 was 1 out of 6. I keep mistaking that. I forget about this first die business. Minus the overlap, which was 1/12. So this would be 2/12 and 2/12. That's 4/12. Minus 1/12 is 3/12, or 1/4.